Okay, I think we're officially at the Berkeley time, and the number of guests are okay, plateauing almost. And Carlos, you can keep on adding, I think, admitting it. And so I'm gonna start. All right. Good morning, everyone. It's so great to see so many faces. My name is Elçin Ünal. I'm an associate professor at the Molecular and Cell Biology Department, and I'm currently serving as the head graduate advisor. Thank you for being a part of this event to celebrate our graduates' accomplishments at time at Berkeley. The graduates, congratulations to each and every one of you. Earning a PhD is a remarkable achievement. Importantly, earning one in the area and the era of a global pandemic with all its restrictions and life-shaking events is an extraordinary achievement and speaks a ton about your resilience. For most people who haven't been through this journey, PhD may appear as a largely intellectual achievement. Certainly, the PhD provides its intellectual challenges. Yet, I think the primary challenge in earning this degree is, in fact, emotional in nature. Normally, when people think of school, they think about taking tests and getting good grades. However, when it comes to pursuing your own research, suddenly, getting good grades loses a whole lot of relevance. Earning your PhD is a lot more like getting plopped down in the middle of a dense forest. There's no map, no compass, no GPS, and you have to find your way out. Your first 50 tries to get out only leads you to more dense forest. If we're honest with ourselves, research is 95% failure at best. But you get better, you make headway, and eventually you find your way out of the forest. Maybe you got some help here and there, but ultimately it was you who was alone in the forest. And being here now on the other side of that journey, and you having something that is truly valuable in this world, which is earned confidence. So if you ever get dropped into another forest, you know you can find your way out. Now the fear is gone. Before, we were your teachers, and now you are our colleagues. So congratulations again on these outstanding achievements. We're very proud of you and wish you the very, very best. So let's give a big hand to our graduates. I would like to now call to our virtual podium Dr. David Rubin, Professor of Cell and Developmental Biology and co-chair of the MCB department, who will be giving the welcoming remarks and will also introduce our keynote speaker, Dr. Tracy Johnson. David, the stage is yours now.
Thank you very much, Elçin. I'd like to welcome our students and our proud family and friends to this graduation ceremony for the Molecular and Cell Biology Department and Helen Wills Neuroscience PhD graduates. This is truly a joyous event. To our graduate students, I'd like to thank you for your amazing contributions over these last years in research, mentoring, teaching, and general service to the campus and our surrounding community. To the families and friends of our graduating students, thank you to the families for raising such a remarkable group of highly talented and committed students and for supporting them through their journey. The MCB department and our neurosciences program are consistently ranked among the best in the country. Because admission to these programs is so highly competitive, we're able to recruit students of great potential to our PhD programs. Our PhD graduates go on to have highly satisfying and impactful careers and to make spectacular contributions through a whole host of career paths. Our faculty are noted for great achievements and are often recognized with the most prestigious awards, including our latest Nobel Prize just this year. What attracts these faculty to Berkeley and what keeps them here? And what makes their achievements possible? It is first and foremost our highly talented and dedicated graduate students who work countless hours in the labs, pushing forward the boundaries of our understanding of molecular and cell biology and neuroscience. I can say personally that it is such a joy to come to work every single day and to watch you, our graduate students, our PhD students, grow and develop skills that will prepare you to go forward and have these satisfying and impactful careers. As a faculty, we are inspired by your curiosity, your creativity, your excellent questions that keep us on our toes and ensure that we are learning from you as much as you are learning from us. We take great pride and satisfaction in your achievements, which will be highlighted in today's ceremony. As Elchin said, in the best of times, earning a PhD is in itself an enormous achievement. Over the course of 5 or 6 years, PhD students perform original research and gain many skills, but they inevitably experience many challenges and highs and lows along the way. They typically will gain and lose and regain their confidence in themselves repeatedly, but they'll grow stronger and more resilient along the way. Making original discoveries is not easy. It takes not only intelligence, imagination, and creativity, but it also takes a tremendous amount of hard work and perseverance in the face of many setbacks. Now, on top of these already imposing challenges that go along with a PhD, what is so impressive about this year's graduating class is that you have faced extraordinary additional challenges. First, you faced campus shutdowns due to smoke and wildfires. We sometimes forget about that because right now we're in a crippling global pandemic that challenged you in your personal lives and isolated you from family and friends, and also caused numerous setbacks and challenges in your professional lives, including switching to remote mode in research and teaching, making progress in laboratory science when access to the laboratory is cut off or limited is really hard. On top of these challenges, during this period when you were in graduate school, there were issues that emerged nationally with racial justice that dominated the news and compelled many of you to take a stand and to take action. We were also traumatized by great division in our country, which challenged our values, our humanity, and even threatened to undermine democracy. Science and truth were under attack. These were not ordinary times. Even when you could return to the lab, life was far from normal. You dealt with social distancing, mask wearing, and you're still dealing with these things, by the way, hand washing, hand sanitizer, density budgets, working in shifts, one person per bathroom, one person per elevator, and of course, the endless Zoom meetings that replaced our in-person meetings, and even your graduation is on Zoom. Many of you during this period faced loneliness and isolation. You had worries about your own safety and the safety of your loved ones. Distances seemed much greater because travel was not possible. You did not get to attend in-person research conferences during the final stretch of your PhD careers, which is really tragic because that's typically when students get to go out and give talks on their research, although hopefully many of you did this through remote conferences. Yeah, and so you did not see your families, friends, and mentors in person for over a year. But through these times, a number of you found ways to help out through the pandemic, through activities such as screening, hand sanitizer production, and so forth. And that's really impressive and inspiring. Thank you very much. Despite all of these challenges in these times of crisis, you succeeded. And that is so impressive. If you can complete a PhD under these circumstances, what can you not do? And now science is prevailing over the pandemic as vaccines have been rolled out, and we're entering a hopeful transitional period towards normalcy. You not only understand at a deeper level than the vast majority of people how science tangibly through the development of mRNA vaccines, new screening technologies, and therapeutics and such has helped humanity during these times, but importantly, you are now qualified to use your knowledge and skills to contribute to the betterment and protection of society by making fundamental discoveries and by translation of scientific knowledge into practical solutions for many problems, including human health and environment, and through education and outreach, which are part of the fabric of the Berkeley campus and aspects that we hope that you will take with you throughout the rest of your career. As a faculty, we have been humbled by your resilience, and we are eternally grateful for all you have achieved and have contributed to the research, teaching, and mentoring missions of the campus. We've been privileged to be part of the journey. Today then, I would like to introduce our commencement speaker. Today's commencement speaker is Tracy Johnson, an MCB PhD alumna herself, who exemplifies the very best qualities of our current graduating class. Professor Johnson is on the faculty in the Department of Molecular, Cell, and Developmental Biology at UCLA, where she holds the Keith and Cecilia Terasaki Presidential Endowed Chair in the Life Sciences and is a Howard Hughes Medical Institute professor. She earned her bachelor's degree from the University of California, San Diego in biochemistry and cell biology, and her PhD here in the Department of Molecular and Cell Biology from UC Berkeley while working in the laboratory of Dr. Michael J. Chamberlain. She was a Jane Coffin Childs postdoctoral research fellow at Caltech, where she worked in the laboratory of Dr. John Abelson. Dr. Johnson joined the biological sciences faculty at UC San Diego in 2003, and then the faculty at UCLA in 2013. Her lab focuses on understanding mechanisms of gene regulation, particularly RNA splicing, chromatin modification, and the intersection between these reactions. Dr. Johnson has served on a variety of scientific boards, including the RNA Society Board of Directors, the HHMI Professors Executive Board, the National Cancer Institute Board of Scientific Counselors for Basic Research, the Johnson Comprehensive Cancer Center, and recently served as chair of the Molecular Genetics NIH Study Section. She's the recipient of numerous awards, including the NSF Career Award, the Presidential Early Career Award for Scientists and Engineers, the Chancellor's Associates Award for Excellence in Undergraduate Teaching. Dr. Johnson directs several academic programs at UCLA and is that embed research into the undergraduate curriculum. In 2020, she began her appointment as Dean of Life Sciences at UCLA. Dr. Johnson, thank you so much for honoring us with this commencement address this year. It's great to have you back.
Thank you so much for that really kind introduction, and it's a pleasure and an honor to be here. And so to the molecular and cell biology and the neuroscience graduating class of 2021, I want to say congratulations. As I was thinking about what I wanted to say here today, I really started to reflect on where I was when I was in your shoes many years ago, both taking stock of the moment and thinking about the future. So I graduated from MCB over 2 decades ago, and honestly, it is really hard for me to believe that it's been that long. I still remember my practice prelims with the Chamberlain Kane labs, getting seemingly random, but very helpful mini science pop quizzes in the hallway from Jeremy Thorner, and being in awe of the way complex cellular processes seem to just give up their secrets through the elegant genetics from Jasper Rhine's lab. But it's only when I think about what we didn't know that I'm really struck by the passage of time. You know, there was no CRISPR. I mean, of course, there was the biology existed, but we didn't understand it or know about it. The human genome wasn't sequenced, and we were really in the rather early stages of the project. And in fact, the yeast genome sequence was published, and I'm embarrassed to say that during the seminar, I turned to one of my classmates and asked, "Do you think this is going to be useful?" So this is all a reminder to me, and hopefully to you, that time passes very quickly. And that's why it's at times like this, a commencement, a ritual transition from graduate school to whatever comes next, that it's important to stop and reflect and to mark time. So I'm sure that none of you were expecting this commencement to be quite like this when you started graduate school. And yet here we are in the moment with this opportunity to take stock and reflect on what we've learned. And as you are all about to start this next amazing phase in your scientific career, whatever that is, I'd like to explore just a few ideas together about the lessons we've learned and how to take these lessons into the future. So I want to just start by acknowledging that there has been extraordinary amount of loss. But today, I would also like to take this opportunity to think about, in the last 18 months or so, not only what we've lost, but also what we've found. If I could summarize one critical lesson learned during this period, it's just how connected we really are and the power of that connectedness. I mean, just thinking about the science of the situation gives the most clear example of this. We literally breathe the same air, which is problematic for a virus that spreads through the air. I mean, if a mutation arises and spreads in the UK or Brazil or India, it's not their problem, it's a collective problem. Yes, this virus has reminded us that we are connected in incredible ways. But the very thing that makes us vulnerable to the virus is the same thing that saves us. After all, it was a scientist in China who published the sequence of the virus and then shared the sequence, and that provided a critical step in the development of the vaccine. The speed with which we've learned how the virus replicates and is transmitted and how the immune system mostly effectively combats the virus has come from our connection as a scientific community, sharing data and ideas at an unprecedented rate, in many cases through open access forums. But besides the scientific connectedness, our social connectedness has been one of the pandemic's most enduring lessons. To say that we as humans are social beings is an understatement. And the profundity with which we felt this pandemic through forced social distancing really emphasizes this. I mean, I think for myself, the thing that I've missed the most about science has been seeing my lab in 3 dimensions. And many of you, as we've heard in the lovely introduction, have been deeply engaged with your communities, connecting what you know and what you do as scientists to the broader community. So our connectedness has also brought into stark relief over the last 18 months something else. Nearly a year ago, the world witnessed the death of a Black man in police custody. And the killing of George Floyd ushered in a racial awakening and a reminder that racial injustice isn't just the problem of someone else or those people, because what we saw reached into our core and connected us in a deep way in both horror and pain. People from all backgrounds came together, donning masks in response to the deep injustice and the demands for change. So there have been some really important lessons learned in the last 18 months. And the question is, what do we do with what we've learned? First, these lessons in connectedness remind us that we as scientists are not doing our work in isolation. We are connected to the larger community that quite literally supports and depends on our work. In that, there is incredible power and responsibility. It is critical that we as scientists double down to communicate truth, not just to each other, we're good at that, but to the broader population. The second lesson is clearly, not to take each other for granted. And it may seem so obvious, but not to do so in the research space, in our labs, in our institutions, but also in our personal lives, our families, our friends, and the people we care about. And thirdly, to recognize the toll that injustice takes, not just on them or those people, but on all of us, and lean into social change. Connectedness is one of probably many lessons that you've taken from this period. It certainly is one that resonates with me. And I hope that you'll take this time to reflect on what you've learned and how to take these lessons into your future as scientists and as global citizens. You, the class of 2021, are embarking on an incredible adventure with a world-class education in hand and extraordinary lessons learned. Now what? So I've been thinking a lot about the qualities that are going to be really important as you embark on the next stage of your scientific careers, your scientific journeys. And I'd like to just share 2 of them. The first quality is that of curiosity. So let's start by first defining what I mean by curiosity. Curiosity is the state to know, curiosity is the desire to know and understand. It is the quality related to inquisitive thinking, such as exploration, investigation, and it implies an openness and a willingness to receive new knowledge. In a significant way, curiosity is what's gotten us to the science that will most likely get us through the pandemic. I've heard, as many of you, I'm sure, have heard from friends and family and acquaintances that the vaccine was developed very quickly, but that's not true. The vaccine was decades in coming because of the work of curious basic scientists who love challenging questions. It took people fundamentally curious about how the immune system works to understand what it takes to make an effective vaccine. It was people who were curious about the mechanisms of transcription and RNA processing and RNA modification and translational regulation that have led to an RNA that can be synthesized and translated and packaged for delivery to make a vaccine. So curiosity has laid the groundwork for one of the most consequential biomedical developments of our time. Great science comes from being curious. In groundbreaking work that was published a few years ago in Neuron, the benefits of curiosity were beautifully articulated. The brain's chemistry literally changes when we become curious. People are better at learning and remembering information that they're curious about. Curiosity, the paper showed, sparks creativity and problem solving. So as you look into your future as scientists, be curious. But it's important to remember that curiosity is not easy. Ian Leslie, in his book, Curious, The Desire to Know and Why Your Future Depends on It, describes curiosity like this. It disdains the approved pathways, preferring diversions, unplanned excursions, impulsive left turns. Curiosity means being just as interested in the journey as the destination. Recognizing that with each diversion, left turn, unplanned excursion, there is the opportunity to learn even when we falter and make mistakes. Curiosity is critical in science and in our social interactions as we navigate this interconnected web of humanity with all of its beauty and its messy complexities. So the second quality I'll share is actually related. It's to be courageous. So first, let's define what we mean by courageous. Webster says, it's the ability to do something difficult, scary, or uncomfortable. It's strength in the face of pain, danger, or uncertainty. So why is being courageous so important? Well, if we're going to be curious and try to understand and take on with openness and sincerity the challenges that face us, and yes, sometimes veer off path, we're going to have to be courageous. So science, of course, as you've all spent many years now learning, can be challenging. And sometimes we'll get it wrong. In the course of your career, you're going to veer into uncharted territory, not only in your science, but in your career choices. Sometimes it'll look like challenging the dogma of a famous person in your field, or pursuing your research, even when your chair says it's not exciting enough. Or it's deciding to leave the career path that you thought you were going to be on to embrace some new opportunity. All of that is going to take courage. So there's also one scientific problem that will take courage. As you heard in the introduction, I'm interested not only in the fundamental questions of molecular and cell biology, but also in addressing the very culture of science and the inequities of who has access to science. For example, one of the statistics that's long troubled me, and I know that many of you in the Zoom share this concern, is why is it that despite equal interest in science, why is it that some students from historically underrepresented backgrounds leave science at more than twice the rate of students who are well represented, who come from well-represented backgrounds? Curiosity dictates that we explore to understand the issue deeply, and then to be willing to challenge our own assumptions. So some of the answers will tell us that the problem isn't the students, that it is in many cases the culture we create that isn't inclusive. Being courageous means that we have to get comfortable with being uncomfortable. Being courageous means that we have to be willing to undertake bold solutions. And let's be clear, change is hard. And why? It's because changing culture is hard. And I think of this story that really, I think, illustrates it. So it's a story, there are two fish and they're swimming along in a pond, and along the side of the path is a turtle. And the turtle shouts, "Good morning, gentlemen. How's the water?" And the two fish swim on for a bit. And then eventually one looks at the other and says, "What on earth is water?" So the water is the culture that we inhabit. And it's easy to take it for granted that that's just the way things are. But for science to really reach its fullest potential, to touch lives, to be inclusive, to reflect the diversity of this nation, we are going to have to examine the water. And so as the next generation of scientific leaders, the decisions you make at the bench and beyond the bench will shape the future and the culture of science, the questions we ask and the way we ask them, and who gets to ask them. And for you to have impact, it's going to take courage. So being curious and being courageous means that sometimes, yes, we're going to falter, and sometimes we're going to fail, and sometimes fail epically. You know, I love this quote from Jaime Escalante. He's a famous American educator. He taught high school in calculus in East LA. And he said that falling is not the biggest problem, as long as you get back up. And as I started this talk about our interconnectedness, it means that the best way to get back up is with community. And so I encourage you to find your people, those mentors, those loved ones, the colleagues who support you and share your curiosity and your courage. And yes, those same individuals who will help you get back up when things get really hard. And they will. And change is hard, but change is important. On April 23rd, 1910, Theodore Roosevelt gave one of the most important speeches of his career. It was a difficult time in the world. The winds of war were swirling, and a few years thereafter, the flu pandemic would grip the world, much like the recent pandemic that's gripping ours. And the talk that he gave was entitled Citizenship in a Republic. And as we talk about our responsibility as scientists and as leaders and how you approach your scientific careers, I think of Theodore Roosevelt's speech. And there's one particular part that I would like to highlight. And this part of the speech is one of my favorite speeches. And it's been called the Man in the Arena speech. Some of you may have heard it, but I'd like to share it with you. It is not the critic who counts, not the man who points out how the strong man stumbles or where the doer of deeds could have done them better. The credit belongs to the man who is actually in the arena, whose face is marred by dust and sweat and blood, who strives valiantly, who errs, who comes up short again and again, because there is no effort without error and shortcoming. But the credit belongs to the man or woman who does actually strive to do the deeds, who knows great enthusiasms, the great devotions, who spends himself in a worthy cause, who at the best knows in the end the triumph of high achievement, and who at the worst, if he fails, at least fails while daring greatly. In the last year, science has achieved the extraordinary. And you, graduates of the 2021 class, Molecular and Cell Biology and in Neuroscience, you have achieved extraordinary things personally, professionally, academically, scientifically, in the midst of unprecedented circumstances. May these lessons that you've learned help you to dare greatly with a sense of curiosity and with courage. And we have no doubt that you will do amazing things. So congratulations.
Wow, thank you, Dr. Johnson, for this incredibly moving keynote address. I literally have goosebumps on me right now. This was amazing. Thank you again. So now I'm going to announce the recipients of the MCB Graduate Commencement Awards. And we're going to start with the Ellen Bearden Book Award. This award is presented annually to a graduating student who has done outstanding PhD research in the area of biophysics. The recipient of this award is selected by Professor Susan Marquesi and Steve Browen. This year's Ellen Bearden Book Award goes to Matthew Summers, who has performed his PhD studies in Professor Marla Feller's lab. Congratulations, Matthew, for this outstanding achievement. Let's give him a round of applause. So our second award is the Nicholas Cosarelli Prize, which is presented annually to a graduating student for best PhD research and dissertation in molecular and cell biology. The recipient of this prize is selected by the chairs of the MCB department. And this year's Nicholas Cottarelli Prize goes to George Otto, who has performed his PhD studies in Professor Gloria Brar's lab. Congratulations, George, on your outstanding achievement. And our final award is the Chris Alvaro Memorial Prize, which is presented annually to a graduating MCB student who embodies both the excellence in research and the commitment to diversity, inclusion, and sense of community that Chris Alvaro epitomized. The recipient of this prize is selected by the MCB Graduate Affairs Committee. And this year's Chris Alvaro Memorial Prize goes to Christopher Duncan Lewis. Christopher, congratulations on this outstanding achievement.
Thank you.
Wonderful. In addition to the students who have received these departmental citations, all of our graduates should be recognized for their extraordinary accomplishments and contributions to our department in terms of their research, teaching, and service. On a personal note, I truly admire the activism work that many of our graduates are involved in. These efforts and initiatives have undoubtedly led to positive changes in our departmental climate and culture and continue to do so. So let's give another big round of applause to all of our graduates. So now we're going to start our ceremony and follow alphabetical order based on the graduate's thesis research lab. So the plan is as follows. I'm going to first read the name of the graduate, their thesis lab and dissertation title. Then the graduate's thesis advisor will say a few words. I will then follow up with a question for the graduate that was picked by them from a list of questions that I provided. So we're gonna begin now. And so our first PhD is Greg Tellian from the Adesnik lab. Greg has been a graduate student in the neuroscience PhD program at the Helen Wills Neuroscience Institute. The title of his dissertation is Sensory Coding and Modulation in the Whisker, Motor, and Sensory Cortex. Greg's advisor, Hilal Adesnik, is now going to make a few remarks. Hilal, the stage is yours.
Thank you. Congratulations, Greg. It's been such a fantastic ride. You really helped get their lab off the ground from the very beginning, nearly 8 years ago. I'm so excited to see what you'll do in the future. You've done so much fantastic work. You could have gotten your PhD years ago. I'm glad that you didn't, because I really am just so excited. You're such a fun person to work with, and I wish you the best. And really, I'm glad you're not going too far away. I'm really looking forward to seeing the science that you do next. So congratulations to you and your family.
Thanks, Hilal. And now I have a question for Dr. Tellian. And my question is, what are you looking forward to now that you're done with graduate school?
Well, thank you for those kind remarks. I'm really looking forward to starting my new position as a postdoc at UCSF. I'm going to be exploring new brain areas that I haven't researched before. I'm really looking forward to learning and contributing to a new subfield of neuroscience.
Wonderful. Thank you, Greg, and congratulations again. Our next PhD is George Otto from the Brar Lab. George graduated from the MCB program in fall 2020, and the title of his dissertation is Endoplasmic Reticulum Remodeling During Budding Yeast Meiosis. Now, George's thesis advisor, Gloria Brar, will say a few words. Gloria?
Thank you. So George worked on 2 projects for his thesis, actually. He first worked as part of a team and showed that this strained regulatory mechanism that relies on a toggling between 2 different transcript isoforms is commonly used to drive protein levels in meiosis. And then he went on to focus on the biology of the ER, and he showed really remarkably that the ER is fragmented and selectively destroyed as part of the normal meiotic program. Now, as a scientist, George is thoughtful and talented. He often noticed important aspects of data that he collected that I completely missed. And he managed to masterfully integrate a complicated set of findings like this to build an understanding of ER biology and meiosis that I think is really beautiful and just weird enough to be exciting. George is also a gifted writer. He often crafted sentences that I was jealous I didn't come up with earlier. And he is as remarkably thoughtful and talented as a person as he is as a scientist. And one feature of George's personality that I'm going to especially miss is that he is so funny. He's absolutely irreplaceable in the lab. But I'm glad that I had the chance to work with him and so excited to see what he's going to do next.
Wonderful. Thank you, Gloria. And so here's my question for Dr. Otto. What is your most favorite tool or equipment in the lab and why?
Wow. Thank you so much, Gloria. That's so nice. I think I gave this answer like a year ago at my commencement. I don't really remember what I said. I think I said my paint pens that I use to label my tubes with, because it just adds like such a nice, I don't know, fun pop of color and excitement to experiments that are normally, you know, without that, really boring. So yeah, I'd say paint pens.
Thank you, George, and congratulations again.
Thank you.
Awesome. Okay, our next PhD is Mia Ploss-Holmes from Jamie Kate and Nick Ingolia's labs. Mia graduated from the MCB program in summer of 2020, and the title of her dissertation is Non-Canonical Roles and Variants of Core Translation Initiation Factors. Now, Jamie Kate will say a few words about Mia. Jamie?
Great. Well, it's really a pleasure to be able to introduce Mia to all of you. When she rotated in my lab, she began working on a project that I think it was a surprise to both her and me that it would end up being central to her thesis. And she had joined Nick Ingolia's lab and mine to explore non-canonical regulation of human protein synthesis. And she worked on how human eukaryotic initiation factor 3, or EIF3, regulates translation of the messenger RNA encoding the ferritin light chain, which is called FTL mRNA. So she used biochemistry and cell-based experiments, and she discovered that EIF3 actually represses FTL translation by binding a structural element in the mRNA. Amazingly, she was able to identify mutations in the FTL mRNA known to cause hyperferritinemia, and these directly impact EIF3 binding and regulation. This is the first case where a specific EIF3 mRNA interaction has been connected directly to a human disease. Mia also began work to understand how the non-canonical translation initiation protein EIF4E3 affects translation in human cells, a project now ongoing in the Ingolia lab. It was really wonderful, Mia, to have you in the lab. You always had a calm presence at the bench, even if it was sometimes your poker face. And you're a wonderful mentor to undergrads and others in the lab. And I really am looking forward to following your success as you move forward in biotech.
Great. Thank you, Jamie. And so here's my question for Dr. Ploss-Holmes, and that is, what will you most miss about Berkeley?
Hi, thank you so much, Jamie, for such sweet words. What I'll miss the most and what I've missed the most since the summer has been just seeing everyone I've met and all the friends and coworkers and everyone in the past 6 years that I've been at Berkeley. It's been a big change. I miss them all, and they've been a great source of support and just happiness throughout my career. And one thing that I've surprisingly missed more than I thought I would was actually lab meetings. So I actually can say I miss them now.
Thank you, Mia, and congratulations again. So our next PhD is Mandy Boone-Tanrart from Jacob Korn's lab. Mandy graduated from the MCB program in summer 2020, and the title of her dissertation is Flipping the Hemoglobin Switch and Discovering Regulators Involved in Fetal Hemoglobin Reactivation. Now, Jacob Korn will say a few words about Mandy.
Thank you. Mandy is creative, fearless, sharp, and driven. Her main PhD project looked at regulation of hemoglobins, which are the molecules in your red blood cells that carry oxygen. She discovered how the red blood cells regulate a special form of hemoglobin that can protect against disorders such as sickle cell disease and beta thalassemia. Her work yielded very deep fundamental insights and could one day lead to new therapies for these disorders. Finding ways to make her science matter in the world has always been important to Mandy. Mandy earned her degree from Cal, but she moved with my lab from Berkeley halfway across the world to ETH in Zurich, Switzerland in 2018. During this process, she managed to somehow keep every ball in the air during the move and somehow made it seem completely effortless and easy. I'm consistently impressed by how sanguine Mandy is about both big and small sources of stress. During her PhD, Mandy also developed beyond the bench. She now runs a miniature lab of her own inside my group, where she supervises several master's students who work on sub-projects of her bigger goals. Her management style is simultaneously supportive and constructively critical. Her students admire her as a mentor and as a leader. She also has, on a personal level, top-notch skills at cooking and photographing dishes of eggs. Coming back to the therapeutic potential of Mandy's research, she was recently awarded a prestigious ETH Pioneer Fellowship. This provides seed funding towards starting her own company, and several groups are already interested in the real-world potential of Mandy's work. Mandy, congratulations on your PhD. All the best for your very bright future as a scientist and entrepreneur.
Wonderful. Thank you, Jacob. And now here's my question for Dr. Boone-Tanrart. And that is, what are the most memorable moments from your PhD?
Thank you so much, Jacob. Definitely some of the big moments that would make this list would be, joining Jacob's lab during awkward week, fall exam, having my paper accepted, and finally my thesis committee signing off on my graduation. But I have to say the most memorable moments were actually the small ones that happened all the time with lab mates and friends that I made during my grad school journey. Little things like our coffee runs to Yali's, grabbing beers at Pacific Standard, and countless beer hours and barbecues we spent just hanging out or commiserating together. And those are truly some of my favorite memories of grad school. Thank you so much.
Wonderful. Thank you, Mandy, and congratulations again. So our next two graduates are from the Feller Lab, Malak El-Kwasni and Matthew Summers, who are completing the neuroscience and MCB PhD programs respectively. Malak's dissertation title is The Role of Dendrites in the Organization of the Neural Circuits for Motion Detection in the Retina, and Matthew's dissertation is entitled Retinal Mechanisms Shaping Neural Encoding of Motion. Now, Marla Feller is going to say a few words about Malak and then Matt. Marla?
Let's see. Got it. Okay, so Malik has journeyed farther than any graduate student before in my lab, starting her journey as a scientist in Cairo, Egypt, through Boston University, and now receiving her PhD from the University of California at Berkeley. Malik was the recipient of a UC Berkeley Chancellor's Fellowship, the recipient of a pre-doctoral fellowship from the NIH, and the recipient of an Elizabeth Robos Einstein Award in Neuroscience relating to human development. Malik's research has addressed a fundamental question in neurobiology, how the shape of neuronal dendrites influence the organization of synapses onto that neuron, and ultimately its computation. She's the first author on 2 studies based on her thesis work. She has also made a tremendous effort in service and outreach. She's acted as a mentor for younger scientists on campus and across the Bay Area. In addition to being a scientist, Malik is a writer, an artist, and a poet, and the source of positivity in all communities that are fortunate to call her a member. It has been a joy and privilege to have such a broad-minded and brilliant scientist as part of my lab. Let's see, Malik will continue her research journey at the Institute of Photonic Sciences in Barcelona, where she will explore how mechanical forces influence brain development. Mabruk. Do I go on to Matthew's directly now?
I can sort of start with a question
Okay.
for Malak first. Congratulations, and this was a very, very great speech, Marla. And Malak, my question is, what is your most favorite piece of data from your PhD work and why?
Thank you. Thank you so much, Marla, for the kind intro, as always. My favorite piece of data from my PhD work for sure was the biggest finding of my paper, where it's basically when you raise animals in complete darkness, the shape of the dendrites change, but actually that doesn't affect anything, which means that the retina is very robust to changes in sensory experience. So that moment was a very beautiful moment, but also following that moment is like hundreds of experiments to make sure that it's real. So yeah, thank you so much.
Great. Isn't that always the case, right? When you get the best piece of data, you got to do more, but that's how we get there. Great, congratulations. And now Marley is gonna say a few words about Matthew.
Okay, so Matthew is one of very few scientists who can comfortably span descriptions of neural function from basic biochemistry to complex systems. This superpower was evident when Matthew was the TA for a challenging undergraduate course where Matthew had to explain what a cell is to physicists and what driving force is to biologists. He received a teaching award for these efforts. Matthew's research is focused on understanding a canonical computation performed by a neural circuit, and that's the ability to discern that an object is moving. This work is based on carefully designed experiments, computational modeling, and a recording technique called dynamic clamp that allows for a direct test of predictions of the model. He proposed this project in his NSF proposal, which he won, and it has been a thrill to see the results of this study come together. Matthew has also been an active member in the MCB community, serving on many committees, and most recently, these efforts have been dedicated to improving climate. This pandemic has been a struggle for all of my students, and Matthew has really risen to the challenge. Let's see, oh, he's a positive force within the lab, mostly by keeping everyone laughing. And for this, I am greatly indebted. So Matthew will stay in the lab through the summer before he embarks on the next step of his journey, in which whatever lab is lucky enough to attract him. Congratulations.
Thank you, Marla, and congratulations, Matthew. And I have the same question for you, and that is, what is your most favorite piece of data from your PhD and why?
Thank you, Marla. It's been a great PhD. My favorite piece of data is actually from 6 years ago during my rotation in the lab. The first time I patched a cell in Marla's lab, which is a technique sort of like sticking a small wire in a balloon without popping the balloon. And the first time I successfully did this, I printed out the data I got, and then it's been hanging on my fridge for the past 6 years. So thank you.
Great, thank you. And let's congratulate one more time Dr. Al Quesney and then Dr. Summers. All right, so we have another tandem set of graduates now from the Glausinger Lab, Christopher Duncan Lewis and Ella Hartanian, who earned their MCB PhD degrees in fall 2020 and summer 2020, respectively. Christopher's dissertation title is Cytoplasmic mRNA Decay Represses RNA Polymerase II Transcription During Early Apoptosis. And Ella's dissertation is entitled RNA Decay During Gamma Herpes Virus Infection Reduces RNA Polymerase II Occupancy of Host Promoters, but Spares Viral Promoters. We already congratulated Chris on receiving the Chris Alvar Award. And I also want to note that Ella was the recipient of the Cottarelli Prize last year that we didn't get to announce during our ceremony. So now Britt Glausinger is going to say a few words about Chris and then Ella. And Britt, the stage is yours.
Thank you, Elchin. Chris, you are an exceptional scientist. You're motivated, rigorous, and a tour de force in the lab. You're also an exceptional person. Your dedication to advancing diversity, equity, inclusion, and belonging in MCB and beyond has influenced the trajectory of countless students and inspired those around you. Your extensive contributions as a summer research coordinator and tutor for the Bridges to Baccalaureate or B2B program, as well as your engagement with SACNAS and Abercrombs and your service to the Chancellor's Advisory Committee on Student Mental Health are emblematic of your deep commitment to teaching, educational outreach, and activism. You've matched these activities with a remarkable tenacity at the lab bench. For Chris's thesis project, for those of you who don't know, he defined a conserved gene regulatory mechanism by which cells respond to apoptotic threat by activating a positive RNA feedback pathway involving cytoplasmic messenger RNA degradation and suppression of transcription by RNA polymerase II. Chris operated throughout his PhD with an extremely high degree of independence, implementing a model system that was unique amongst my lab's projects. His scientific successes have enabled him to land a position at 23andMe Therapeutics, where I'm confident he will continue his impressive trajectory. Congratulations, Chris. I am so, so proud of you.
Thank you, Britt. So Dr. Duncan Lewis, what are you looking forward to now that you're done with graduate school?
Thank you, Britt, by the way, almost made me cry. Pay raise would be the #1 thing. I'm glad to say that has come true. The Audi is testament to that. But I just wanted to say a few words about Chris too, if I could. I actually had the privilege to know Chris. And if I could pinpoint any one particular moment that encouraged me to come to Berkeley, it was my conversation with them at my interviews, my interview cohort's recruitment party. And besides being like fabulous and probably the coolest person I had ever met, they just exuded this warmth, this effervescence, and really, really communicated to me that Berkeley was a place to go for people seeking acceptance for their race, their sexuality, their gender expression, or anything else. So it's really a great honor to receive a prize dedicated to this amazing person and to be a part of a department that honors their legacy by constantly working to make science a more accepting place. So, and to everyone still in the department, I hope you keep it up.
Thank you, Chris. That was wonderful. Okay, Britt is now going to say a few words about Ella. Britt?
Yes. Ella, I often feel in awe of you. You have been able to simultaneously run so many research projects while mentoring so many students, while organizing so many lab social events, while writing so many papers, while serving as the student rep on things like faculty hiring committees, while judging science fairs or doing classroom volunteering, while raising a family of now 2 small children and maintaining a myriad outside interests. You can somehow balance all of these things and so many others with an aura of confidence and efficiency that most of us can only aspire to. For the rest of you, it's not surprising, to me at least, that Ella completed a really impressive thesis project, and she applied tools spanning genomics and genetics to biochemistry and virology to uncover a fascinating story about herpes viral infection and also subsequently coronavirus infection, how they turn off gene expression in ways that suppress cellular RNA, but largely allow viral genes to escape. And true to her sense of adventure, Ella is now moving across the world to pursue postdoctoral work in immunology in Lausanne, Switzerland. Ella, you are a natural leader, and in this year of great uncertainty, one of the things that I have remained sure of is that you are someone who has and will continue to do great things. I'm so proud to have worked with you. You're a true colleague. Congratulations.
Wonderful. Thank you, Britt and Ella. Or Dr. Hartenian, what was the best moment today in your PhD, and what did you do to celebrate?
Thank you so much, Britt, and thank you for the wonderful ceremony. My favorite moment that I remember from my PhD was passing my qualifying exam and the party that happened afterwards. I remember just coming out of the room and having this, moment of realization that it was over and how it had gone. And then had people coming from all over the department to my and Franzi's joint party out on our balcony. I had a wonderful time with my lab mates, with Britt, with my friends and family from inside and outside the department. And like any good MCB party should, it ended at Molo at who knows what time in the morning. So I will definitely remember this for a long time to come. Congratulations, everybody.
Wonderful. Thank you, Ella. And let's congratulate one more time Chris and Ella from the Glausinger Lab for earning their PhDs. Okay. Our next PhD is Vale Gates from Thomas Griffiths and Alan Collins Labs. Vale is graduating from the neuroscience program, and the title of Vale's dissertation is Formalizing and Testing Computational Cognitive Models of Social Collaboration. Vale's thesis advisor, Thomas Griffiths, is now going to say a few words.
So Vale has been a pleasure to work with from the moment when they first arrived in my office with pages of research ideas and boundless enthusiasm about all of them. The process of turning those ideas into projects and papers has been a lot of fun. Along the way, Vale has enjoyed excursions into topics as diverse as clinical psychology and saving the world from rogue artificial intelligences. It's not a coincidence that they're interested in the foundations of social inference. All of these projects are about improving how we interact with one another, and Vale's curiosity, enthusiasm, and community-mindedness provide a great exemplar of how to succeed in this task.
Great, thank you. And now here's my question for Dr. Gates, and that is, what are you looking forward to now that you're done with graduate school?
Thanks so much, Tom. I'm really looking forward to my new postdoc at Stanford at HA and CSAC, where I'll be doing an ethnography of AI researchers. I'm also looking forward to having the summer off, which will be a first for me, though I'll probably still end up reading a lot about research. Many thanks to everyone who made this PhD as enjoyable as it has been, and I'm very excited about what's next.
Wonderful. Thank you, Vale, and congratulations again. Our next PhD is Maya Emmons-Bell from Ishwar Hariharan's lab. Maya is graduating from the MCB program, and the title of her dissertation is The Role of Ion Channels in Developmental Patterning and Growth. Ishwar Hariharan is now going to say a few words about Maya.
Just before saying something about Maya, I just want to say that many of the students who are graduating today, I met them first while teaching MCB 200, and it's just really wonderful to see them all become, accomplished scientists. So now I'll talk about Maya. Maya did her entire K through 12 education in the Berkeley public schools. So it's really appropriate that her educational career culminates in a PhD at a public university in Berkeley. Maya's a very unusual PhD student in some ways in that she was the one who told me about her project the whole way. Maya brought an idea with her, the idea that membrane potential can regulate development. And she formulated a project that that she could study this phenomenon in the Drosophila wing disc. And this culminated in the demonstration that membrane potential regulates the hedgehog signaling pathway. And it sort of transformed this amorphous field of bioelectricity into a very specific observation and a very specific pathway. This says a lot about Maya. She's intellectually fearless and is willing to embark on in a line of investigation which offers just the slightest hint of success, with lots of opportunity for failure. But nevertheless, she took this project from its very conception through to completion, pandemics or whatever along the way. Maya is a really amazing person. She cares deeply about issues such as social justice. But if you understand the way Maya thinks, this is just an extension of her very selfless personality. She cares about her lab mates. She cares about her fellow students. She cares about her community. And her concerns for social justice are an extension of this. And it's only when Maya leaves that we'll really understand all the things that she's done behind the scenes to help our lab, keep moving. Maya is going to be a postdoc working on tumor models in zebrafish, and I think she's going to do spectacularly well. And thank you very much, Maya. It's been a privilege to mentor you.
Thank you, Ishwar. And now my question for Dr. Emmons-Bell, and that is, what will you most miss about Berkeley?
Yes, thank you, Ishwar. Those words were so kind. I will by far, first and foremost, miss the amazing people, both in and out of the Berkeley MCB community, who have enriched the last 5 years of my life in ways that I can't describe in words. But then second up, I will miss the close proximity that Berkeley has allowed me to the amazing nature, fire trails, ability to get out into nature within a 15-minute walk from campus. That has been integral to my mental health during my PhD.
Thank you, Maya, and congratulations again. Our next PhD is Ryan Muller from Nick Ingolia's lab. Ryan is graduating from the MCB program, and the title of his dissertation is CyberSeq Dissects Genetic Networks by Quantitative CRISPR-I Profiling of Expression Phenotypes. Nick Ingolia is now going to say a few words about Ryan. Nick?
Yeah, so throughout Ryan's time at Berkeley, he's worked to develop creative and cutting-edge new tools for studying gene expression regulation. This actually began with his work as an undergraduate Amgen scholar here, where he worked to develop Cas9-based splicing modulators. And then we were very fortunate that he returned to Berkeley as a graduate student. And here he originally set out to learn how stalled ribosomes triggered the degradation of the RNAs they were translating. And he explored various routes that might offer a way around the roadblocks that had really stalled previous genetic and biochemical work on ribosome stalling. But one of those paths led him, though, to an even richer pasture, which is a really versatile approach for phenotypic profiling of all sorts of different things that we've already applied to many different questions beyond this original one that he was thinking about. And sort of true to form, even as we survey the possibilities opened by Ryan's CyberSeq approach, he is eagerly looking to the horizon with new ideas in mind. And we'll miss Ryan as he leaves us the next stage of his journey, and really look forward to seeing where his creativity, his enthusiasm, and his perseverance bring him next.
Thank you, Nick. And now here's my question for Dr. Muller, and that is, what was the worst moment or day in your PhD, and how did you cope with it?
First of all, thank you so much, Nick. It's been a great pleasure working with you. And I should preface this first before I bring the mood down too much by saying that my story does have a happy ending. So as Nick alluded to, I used to work on ribosome stalling. And in my fourth year, I attended a conference. And by the end of the keynote talk, we realized that my main project had been scooped, quite shell-shocked at the time. But in retrospect, a conference is a great place to restructure your project. I made a lot of fast friends with a great community of sympathetic translation biologists, and had an opportunity to really see like a full view of the field as I pivoted my project. At the lowest point of my PhD, I really appreciate the support from Nick, my lab mates, and the MCB community as a whole that helped me get through it. And so roughly 2 years later, I'm happy to say that I successfully pivoted my project and ended up in a publication I'm very proud of, and like to thank everyone for all their help throughout of it.
Thank you, Ryan. What a great story, and congratulations again. Our next PhD is Melissa Newton from Andrew Kaiser's lab at UCSF. Melissa is graduating from the neuroscience program, and the title of Melissa's dissertation is Neural Correlates of Decision-Making in Human Parietal Cortex. I'm going to say a few words about Melissa on behalf of their advisor, Andrew Kaiser, who is unable to attend the ceremony. So Andrew Kaiser says, wow, where to start? As goes without saying, but which I will say anyway, Melissa should be very proud of the work that has brought her to this point. Her PhD on representations of policy abstraction in the brain, and within parietal cortex in particular, addresses a fundamental question about the cognitive mechanisms that link sensation with action during decision-making. But Melissa is now one of our experts on this topic, and she can tell you about that herself. Instead, I'd like to highlight the tenacity that Melissa showed to get here. She has dealt with serious obstacles over the course of her graduate career, and one of which could have been a reason to give up on her thesis, and any one of which could easily and justifiably have felt more important than functional MRI work on abstract rules. Nevertheless, she persisted. This kind of grit was one of the factors I appreciated when we both took a chance on each other when she joined the lab. And it's one of the reasons I think her thesis worked out as well as it did. And it's one of the reasons I look forward to seeing how she will take what she has learned and taught at Berkeley over the past number of years and apply it to the next phase of her career. Congratulations, Melissa. And now my question for Dr. Newton, and that is, what is the one question that you wish to answer about your PhD project that you didn't get a chance to go after?
Thank you. And thank you to my advisor who couldn't make it because he's seeing some patients right now as part of a parallel study. The one question I wish I could answer about my PhD, I didn't get a lot of chance to do, was to spend more time investigating questions about what happens to your memory contents once they are dumped from your working memory holding space. So when you make a decision, you have multiple options, but the decision process means you only select one of them. So the question I would really have wished more time to pursue is what happens to those other representations in the brain of the unused or decisions. So hopefully that question gets answered from future research very, very soon, because I'm quite curious.
Great. Thank you, Melissa. I also hope that the question gets answered by someone else. And that's, I think, like one of the best parts, right? You pass on the baton to the next trainee in the lab. So thank you and congratulations again. And our next PhD is Tess Linden from Nicole King's lab. And Tess is graduating from the MCB program, and the title of her dissertation is Insights into Animal Multicellularity from Diverse Choanoflagellates. So I'm going to say a few words about Tess on behalf of her advisor, Nicole King, who is unable to attend the ceremony. So Nicole says, Tess doesn't mess around as a scientist. She wants to get to the heart of things and is willing to take great scientific risks to get there. During her doctoral research, she pursued two major lines of research. In the first, an exciting collaboration with lab mates Theobald Brunet and Ben Larson, she discovered and then characterized the ability of a multicellular choanoflagellate to invert in response to light. Not only did this collaboration lead to fundamental new insights into the origin of animal cell biology, but it strengthened the already existing friendship among these three and helped spawn the world-renowned King Lab Word of the Day, in which Tess and others provided tongue-in-cheek definitions for obscure terms for biology and physics. With the mysteries of light-regulated inversion worked out, Tess pivoted to establish a new research project on the glue that holds multicellular organisms together, the extracellular matrix. Her work has demonstrated that choanoflagellates express components of the extracellular matrix that were previously thought to be restricted to animals, and established a research program that promises to reveal how the extracellular matrix functions in these mysterious organisms. Graduate school is a transformative time, and Tess has decided that she can't sit on the sidelines as climate change threatens our planet. Moving forward, she plans to take her expertise on the extracellular matrix to industry, where she will contribute to the development of new plant-based meats. I'm so proud and can't wait to hear about her future success. Congratulations, Tess. And now here's my question for you, Dr. Linden, and that is, do you want to share any embarrassing or fun moments that with us from your time at Cal? Tess?
Yeah, thank you so much, Elchin. So my very first experiment of grad school, I was running a gel with a sample that someone had entrusted me with. This is my very first experiment of grad school, and I ran the gel backwards, and the entire sample ran off the gel. Yeah, that was my very first day of grad school, and needless to say, it was only upward from there. And I've learned so much since then, and this has been just a really invaluable experience. And I'm so glad that I chose to pursue a PhD, and most of all that I chose to pursue a PhD at Berkeley. So congratulations to everybody, and I'll miss you all.
Wonderful. Thank you, Tess. That exact thing actually happened to me as well, so you're not alone. So congratulations. And our next PhD is Mark Stepaniak from Craig Miller's lab. Mark is graduating from the MCB program, and the title of his dissertation is Transgenic and Genomic Analysis of an Adaptive Cis-Regulatory Variant in the 3' stickleback. Craig Miller is now going to say a few words about Mark. Craig?
Thanks, Elchin. So Mark was teaching high school biology in Illinois when he decided to go west to Berkeley to study genetics, development, and evolution. Mark wanted to get a PhD so he could teach biology at the college level. For his thesis work, which was supported by an NSF Graduate Research Fellowship, Mark pioneered transgenic methods in fish to directly compare in the same animal the spatial and temporal activity of two evolved enhancer alleles during development and into adult stages. Mark discovered that an adaptive cis-regulatory allele that accelerates tooth regeneration has evolved spatial shifts in activity during development and regeneration. Mark's work provides deep insight into how cis-regulatory mutations can alter a gene's spatiotemporal expression pattern during organogenesis and regeneration to lead to adaptive changes in morphology. Like all successful theses, Mark's thesis has left us with many more questions to answer than we had when we started. Also in graduate school, Mark collaborated with his wife, Molly, to have baby Calder, who was the star of most of our pandemic Zoom meetings. Mark will be moving back to the Midwest to teach college biology. We will all miss learning from Mark, not just about enhancers, but also about bird watching, hockey, and movies. Congratulations, Dr. Stepaniak.
Thank you, Craig. And now my question for Dr. Stepaniak is, what are you looking forward to now that you're done with graduate school?
I'm definitely looking forward to going back to teaching full time. That's something that I feel like I've really missed while in grad school. And then the other thing I'm looking forward to is this little guy is going to be a lot closer to his grandparents and aunts and uncles. So I think that'll be great for him to meet them for the first time. And I also just want to say thank you to Craig for everything.
Wonderful. Thank you, Mark. And may I say you have an adorable child. And thanks for showing him to us today. So congratulations again. And our next PhD is Lisa Eshun Wilson from Eva Nogales' lab. Lisa graduated from the MCB program in fall 2019. She wasn't able to attend the ceremony last year. And the title of Lisa's dissertation is Structural Studies of the Microtubule and its Regulation. I also want to emphasize that Lisa was the recipient of the Chris Alvaro Memorial Prize last year in 2020. So Eva Nogales is now going to say a few words about Lisa. Eva, the stage is yours.
Thank you, Elton. So Lisa may likely be the most enthusiastic student, actually human being, that I have ever encountered. Her optimism is never ending. Her capacity to start new things and her desire to get involved are equally limitless. In my lab, she worked using structural methods to describe the effect of acetylation on alpha tubulin on microtubule structure and stability. Yeah, and in addition to carrying out cryo-EM structure determination, she coordinated a number of collaborations that expanded the scope of the study to include computational and molecular dynamic analysis. This paper was cited more than 50 times last year. She also started a collaboration with the Yildiz lab to study the binding of MAP7 to microtubules and its effects on kinesin activity that hopefully will be published soon. Beyond research, Lisa was critical to the creation of the MCB program to improve the climate in our department and the sense of inclusion and belonging, and ultimately the success of minority students in the MCB program. I think she was a true catalyst that sensitized us all on hard issues concerning the well-being of our student body and more broadly, how we relate to one another in the department. For this, as Elchin said, she received the Chris Alvaro Award in 2020 as certainly most well-deserved award. Before leaving our lab and before the shelter in place, just kind of a few days before this happened, Lisa and I had a last evening together in San Francisco, just the two of us, and included dinner and then going to the San Francisco Ballet. And it was really lovely. And I will share it that evening, just the two of us forever. For the last year, Lisa has been a postdoc at the Scripps Institute, and she has already caught the attention of academic talent hunters. So I'm so looking forward to seeing more of you, Lisa, and your science in years to come.
Thank you, Eva. And now here's my question for Dr. Eshen Wilson, and that is, do you have any words of wisdom for an incoming graduate student?
Yes, I think Tracy Johnson did such a beautiful job describing things that future our academic community as our community in as a whole is going to now value curiosity and courage. And I would really just love to emphasize valuing courage and bravery. And that would be my main word of wisdom, or words of wisdom, is to be brave. To always be yourself and to fight for what you believe in. And IMCB, Inclusive MCB, the program that Eva alluded to, has been such an incredible opportunity for me to learn more about how I can make the academic space safer and a happier space for individuals like me, and in particular, my younger siblings. So many of them are getting excited about PhDs, and it motivates me to want to make the space safer for them because they are like me. And it's very important that they feel safe. And so IMCB was such a fantastic opportunity, and winning the award has been amazing. I would love to dedicate this award actually to my parents. My mom is absolutely amazing, inspires me every day, and helps me through everything. I would not be here without her. And I'm so grateful to have her in my life. And my father is so hardworking and has instilled a level of resilience. And I get the enthusiasm from him, okay? If you guys think I'm enthusiastic, I'm like only half as enthusiastic as my dad. I mean, I grew up with him working 3 jobs and doing everything he could to keep food on the table. And it was, he also inspires me every single day, and I'm so grateful. I'm also so honored to say that thanks to Eva's continuous and incredible support, I also was awarded the NSF Postdoctoral Award, which gives me funding to actually start a program that I'm calling iScripts. Because what I'm seeing is that there are even a fewer number of women like me, especially who go on to do their postdocs. And they often leave not because they want to, but because they don't feel safe or for financial reasons. And so we are actually going to provide micro grants for postdocs from low income backgrounds. And I'm so excited to say that the opportunities that Eva has given me and the training that she has given me has set me up really nicely in my lab here with Gabe Lander, who is now being very supportive of this as well. And so I absolutely want to be a good scientist, but it's so important that I create an environment around me that makes everyone feel safe and happy, especially because my sisters are very interested in this as well. And I just want to give a special shout out to my sister Francine, who is next to getting her PhD on track. And so I just want to say that she inspires me so much. Sorry, I'll shorten this, but I'm just so grateful for her as well. She has supported me through everything. I love my sisters so much, Sierra and Jeremiah, and my brothers, Jeremiah and Eric and Jasmine. I love you guys so much. And I'm so honored to be a part of this community and to have gotten my PhD from Berkeley. Thank you guys so much.
Thank you, Lisa. You're truly inspirational, and congratulations again. So our next two graduates are from the Ryan Lab, Daniel Saxton and Davis Goodnight, who are completing the MCB PhD program. The title of Daniel's dissertation is How is Heterochromatin Epigenetically Inherited? And Davis's dissertation is entitled Cell Cycle Regulation of Silent Chromatin Establishment in Saccharomyces cerevisiae. Jasper Ryan is now going to say a few words about Daniel and Davis. Jasper, the stage is yours.
Daniel Saxton is the most deceptive student I've had. He comes across as an easygoing, carefree dude skateboarding his way to the lab each day. Yet somehow, without breaking a sweat, he has both started more experiments and, importantly, finished more than any other student in recent memory. So far, he has published 2 impressive papers in which he is the sole author, other than me, and has co-first authored a paper with an undergraduate he mentored. He has 2 other papers in progress. In his first paper, he destroyed the leading model for how an epigenetic state is inherited by the segregation of parental nucleosomes. His work implicated silencer elements as both the locus of transcriptional memory and inheritance. His eagle-eyed attention to unexpected clues among the 1.3 zillion edited genomes he constructed led to his second paper, in which he discovered the sensitivity of transcriptional states to the precise spacing between nucleosomes and the role of nucleosome-free regions to establish the phasing of nucleosomes and the strength of gene silencing. His most recent work unites flow cytometry with ChIP-seq and single-cell analysis of expression dynamics, and has identified previously unknown intermediate structures of silenced chromatin that illuminate their assembly and dynamics. The best graduate students critique each other and look for opportunities to disagree with their advisor. Daniel has excelled. He has helped refine the analyses of everyone at our lively group meetings. And with me, he has been a most agreeably disputatious student who has proven himself correct on nearly every disagreement we have had, to my utter delight. Daniel, we are going to miss you big time.
Thank you, Jasper. And now here's my question for Dr. Saxton. And that is, do you have any words of advice for your thesis advisor?
I'd like to start by saying it's been a really great experience in the Ryan Lab. I really have loved working with you, Jasper, and admire you a lot as a mentor and just such a nice person. But for everyone else, Jasper has a dark secret, which is that he has never done a PCR before. So my word of advice would be for you to try a PCR sometime, just as a life experience. We've moved on from the water baths now, so it's really easy. But thank you so much for a great PhD experience.
Wonderful. Thank you, Daniel. And now Jasper is going to say a few words about Davis Goodnight, his second graduate student, graduating this year.
Scientific mysteries seldom last for 35 years unless their solutions prove to be extremely difficult. Davis Goodnight solved such a mystery. The creation of new cell types occurs when one cell divides to produce two cells, one of which is a new type with a new pattern of gene expression. In 1984, it was shown that the creation of heterochromatin requires that cells pass through S phase, the time when the genome is replicated. But why? Over the years, multiple studies came to incorrect conclusions. Armed with substantial intellect, scientific courage, and no fear of hard work, Davis Goodnight recognized possible flaws in the published work and quickly proved them all to be wrong. But what was the answer? Davis established that the molecular architecture of heterochromatin can be assembled in cells prior to starting their first cell division, but it's not yet functional. Through use of single molecule RNA analysis and highest resolution chromatin measurements, he proved that gene silencing required the dual enzymatic removal of some activating chromatin marks and the replication-driven dilution of others. Through friendship, probing questions, and technical mastery, Davis is an anchor for all members of the lab, assisting our development of new skills and insights. His scientific acumen and judgment improved all of our work. And outside the lab, Davis coupled scientific adventures with the exploration of Sierra Nevada. He developed keen artistic skills, producing compelling paintings of landscapes and a stunning dog portrait, while developing impressive culinary sophistication. His future is so bright he needs sunglasses. Davis, we're going to miss you too.
Wonderful. Thank you, Jasper. And so here comes my question for Dr. Goodnight, and that is, what will you miss most about Berkeley?
Thank you, Elchin. Thank you, Jasper. That was, very classic Jasper. Jasper is always our best cheerleader. It's like you can walk into Jasper's office thinking that you have made an absolute fool of yourself and walk out thinking you've invented I don't know, the newest CRISPR or whatever. So I chose this question because I thought it was going to be sort of easy, but then I realized it's actually sort of profound because I'm going to miss so much about Berkeley. And so I think that the obvious answer is that it is the most incredible community that I've ever been part of. I just love sort of running into everyone in Berkeley that I know, sitting around and so I'm going to love that. Or I've loved that so much, I'm going to miss that so much. And on an especially personal note, the Rhine Lab was just the absolute best place to get a PhD in the world. I realized that I just love walking in there every morning. I'm going to miss that so much. So thank you, Jasper. Thank you, Elchin.
Thank you, Davis. And thanks again, Daniel and Davis, and congratulations. Okay, so our next PhD is Stephanie Engert from Kristen Scott's lab. Stephanie is graduating from the MCB program, and the title of her dissertation is Synapse Level Connectivity in the Gustatory Circuit of Drosophila melanogaster. Kristen Scott is now going to say a few words about Stephanie. Kristen?
So Stephanie's graduate research examined the neural circuits that process taste information in the fly. She really revolutionized our lab's research by using the Drosophila electron microscopy data set to examine the synaptic connectivity of neurons that detect taste compounds. She discovered that taste sensory neurons synapse with each other to regulate sensory information before it ever goes to the brain. For almost a year, Stephanie trained in luxury at the premier Fly Research Institute in Washington, DC. We were really, really happy when she decided to return to our humble lab to change our research with her newfound skills. Stephanie, you have unstoppable energy and you're really a prime organizer of the lab. Stephanie trained the whole lab in EM tracing. She organized a bustling team of undergraduates and turned them into successful researchers and even a high school student. And she won several research awards by proxy. Stephanie's also a social engine of the Scott Lab. She's such a zealot that she even dressed up as her favorite model organism, the fly, for Halloween. Stephanie, for your crucial contributions and prodigious accomplishments, I happily award you a Scotty Lifetime Achievement Award in Connectivity, as well as your PhD. Congratulations, Dr. Engert.
Wonderful. Thank you, Kristen. And now here's my question for Dr. Engert, and that is, what will you miss most about Berkeley?
Thank you, Kristen. You really managed to make me cry now that I have to talk. Well, as many of my classmates have said, what I'll miss most is my friends and the lab and everybody in Berkeley that I know. But I also have to say I'll miss just the really unbelievable level of tolerance for quirkiness in the city in general, so that a jacket like this is completely acceptable to wear on a Monday morning to work, and nobody even bats an eye on the street. So that's quite lovely and empowering. So I'll miss that too.
Wonderful. Thank you, Stephanie, and congratulations again. Our next PhD is Eric Van Dis from Sarah Stanley's lab. Eric is graduating from the MCB program, and his dissertation title is "A novel sting-activating vaccine for M. tuberculosis induces pathogen-specific Th17 cells and provides significant IL-17-dependent protection against infection." Sarah Stanley is now going to say a few words about Eric. Sarah, the stage is yours.
Eric, you're the student who can do it all. For those of you who don't know Eric, he's smart, he's ambitious, and he's really wildly productive. So Eric took on and had success in some of the most challenging projects in my lab. His thesis work centered around trying to understand how CD4 T cells contribute to control of Mycobacterium tuberculosis infection, which is an area of research with long-standing unanswered questions in the field. So in one project, Eric sought to understand the mechanistic basis of a novel sting-activating vaccine for TB. And in a second, even more ambitious project, he established a unique ex vivo system for dissecting CD4 T cell interactions with macrophages. The discoveries that Eric made have contributed significantly to a new realization in the field of the importance of Th17 T cells for immunity and in other ways to our understanding of the myriad functions of CD4 T cells. So in addition to his scientific talents, Eric is an all-around great guy. He is always a team player. He's very generous with his time. I feel really grateful that Eric joined my lab pretty early on in my career here at Cal, because he set an amazing example as someone who can be incredibly productive, get a lot done, while also being collaborative, supportive, and also really fun to have around. So Eric had many projects in my lab. He did lots of year-long experiments in the BSL-3. And as if this wasn't enough, over the last year, Eric was part of a small group of students and postdocs who really literally worked around the clock 7 days a week to establish the ability of pretty much anyone on campus who wanted to do this to work with live SARS-CoV-2 in cell culture models and animal models. And so he was made incredible input to not just my lab, but to lots of labs around the Bay Area. So Eric is going on to a postdoc at the Stetson Lab at the University of Washington. I know he's going to do great things. And Eric, I'm really going to miss you, and I feel really honored to have been a part of your story.
Wonderful. Thank you, Sarah. And now my question for Dr. Van Dis, and this is actually one of my favorite questions. So thanks for picking that. And the question is, what is your favorite moment of truth before you actually know the final results of your experiment?
Thanks, Elchin, and thank you, Sarah. Thanks for everything. It's been a real privilege being in your lab these last 5 years. The moment of truth, yeah, in the Stanley lab, we plate bacteria, and it's Mycobacterium tuberculosis, so we have to double wrap it in foil so nobody gets infected. And then when the colonies are ready to count, you kind of unwrap these foil wrapped stacks of plates like a birthday present, and you wait to see if the year-long experiment that she alluded to was a massive waste of time or not. And a few times in my PhD, I actually got some really cool results. So that's definitely some of the most exciting moments of my PhD is, downstairs in the basement by myself counting colonies and getting some cool data. So thanks again, and thanks, Elchin.
Wonderful. Thank you, Eric, and congratulations again. So our final two graduates are from the Vance Lab, Catherine Dietz and Shelley Margolis, who are graduating from the MCB program. The title of Catherine's dissertation is Spill Your Guts, Cross-Presentation of Intestinal Epithelial Cell-Derived Antigen, while Shelley's dissertation is entitled from sea anemones to mice, evolutionary insights into innate immunity. Russell Vance is now going to say a few words about Catherine and Shelley. First, Catherine. Yeah, Russell.
Great. Well, congratulations, Katie. Obviously, all of us in the last year or so have been hearing a lot about the immune system, probably too much. So you may already be aware, though, that the immune system is divided into two distinct subsystems. There's the adaptive immune system and then the innate immune system. And for her PhD, Katie bravely took on the challenge of studying the adaptive immune system in a lab that really otherwise only knows something about innate immunity. So Katie's success is a testament to her independence and her unflagging perseverance. Katie made a very interesting discovery that a component of the innate immune system, the inflammasome, plays a key role in the induction of subsequent adaptive responses. And I'm in awe of Katie. Her work required some of the most complex genetic and immunological experiments the lab has ever conducted. I certainly could not do these experiments myself. Katie has been also an ideal lab citizen, strongly committed not only to her research, but to the broader scientific life around her. Most notably, she served as editor of the Berkeley Science Review, a really outstanding popular science journal. And also she won the Outstanding Graduate Student Instructor Award for her teaching. So for her postdoctoral work, Katie will be joining Nels Elda's lab in Utah. Everybody in the Vance lab will miss Katie's positive energy and enthusiasm for science, as I will as well. So we wish you well, Katie.
Wonderful. Thank you, Russell. And now here's my question for Dr. Dietz, and that is, what are you looking forward to most now that you're done with grad school? Katie?
Thank you, Elshin, and very big thank you, Russell. So as Russell mentioned, I've been doing classical immunology in mice for now about 9 years, if you count the time that I've been a research technician before grad school. And I'm super excited to move on to a new model organism, zebrafish, which don't bite you. Thank you.
Great. Thank you, Katie. And now Russell is going to say a few words about Shelley Margolis. Russell?
Okay, well, congratulations, Shelley. For her PhD, Shelley initiated and led an entirely new research direction in my lab. She introduced us to a really beautiful experimental animal, which was a sea anemone, Nematostella vectensis, which Shelley cultured continuously in the lab for years, with only a few minor mishaps along the way. Shelley was interested specifically in the question of how sea anemone protect themselves from infection. And this is an interesting question because anemone are more than 500 million years diverged from humans. So her work shed light on the evolutionary origins of immunity. And Shelley found that the immune response of sea anemone is actually unexpectedly similar to that of humans, but also differs in very interesting ways. And in particular, she found that anemones seem to make a broad immune response that is effective against viruses and bacteria, whereas humans tend to make responses that are more specialized to one class of pathogen. Because Nematostella was new to the Vance lab, Shelley's project required remarkable independence, perseverance, and innovation, which are qualities that Shelley exhibits in spades. And Shelley has also been an important leader in the lab, always reminding us to keep our moral compass pointed in the right direction. So we will miss Shelley's scientific insights, her endless good spirit, her friendship, when she moves to Alex Miska's lab in Seattle for her postdoctoral work. And we wish you well, Shelley.
Wonderful. Thank you, Russell. And now my question for Dr. Margolis is, what will you miss most about Berkeley?
Thank you so much, Russell and Elchin. And like everybody else, I'm really just going to miss the community. It's really been an amazing place to do science, where even when you're having a bad day, you know that you're going to go in and see your friends and it's going to be a great time. And we have amazing social events like Follies and beer hours that I'll really miss. But it's really been so nice to be here, and I'm really going to miss everybody, and especially the Vance Lab and Russell. Thank you so much.
Wonderful. Thank you, Shelley. And let's congratulate again Katie and Shelley. Okay, we're almost nearing the end, and I would like to recognize and give special thanks to all of the MCB and neuroscience graduate students who have contributed immensely to the discoveries that make our department such an exciting place to do science. Equally important, these students have also helped us build a stronger and more inclusive community. However, we do know that there's a lot more that we can and should do for a better future. On behalf of faculty and staff, our warmest thanks for all your valuable contributions. Graduates, family, friends, faculty, and staff, thank you all for your participation in this fun and memorable event. I specifically want to thank the Graduate Affairs Office staff members, in particular Hannah Bloom, Carlos Garcia, Eric Bullis in MCB, and Candace Grosskreutz at Helen Wells, as well as special thanks to Karina Galicia, the Director of Student Services, for all their efforts and support in making our graduate program function so well. Finally, I'd like to thank the thesis advisor of our graduates for your mentorship and help with the journey through the forest. Please do not leave just as yet, as I would like to invite back our co-chair, David Rubin, who will offer the closing remarks. David?
After all this, I almost forgot to unmute. Okay. Thank you, Elchin. And I wanted to start just by adding one more thank you, Elchin. Pivoting and putting on a ceremony like this remotely is not as easy as you might think it is. When you're used to doing everything in person. And there's one other person who did a tremendous job to make this so successful and does a tremendous job leading our graduate program, and that's the head of our MCB graduate program, Professor Elchin Unal. So thank you for doing such an amazing job today, Elchin, and running the ceremony so smoothly, and thank you for all the effort and work you put into running our graduate program so well. So thank you, Elchin. In closing, there's not much more to add at this point, but just one thought that occurs to me in these times, it's really easy to be pessimistic about the future. But when you see how gifted all these young students are and how committed they are and how accomplished they are and how passionate they are, not only about science, but you're seeing your dedication to making change to improve society, I don't see how anyone could leave this ceremony being anything other than optimistic about the future. You guys are wonderful, and we all are so grateful for being able to share in your journey, and we are so looking forward to following your careers and your success as you move forward. And so once again, I would like to thank the family and friends of our graduates for your support of these amazing students for these years, and we share your we share in being very proud of these graduates, and we know you all are very proud in what your sons and daughters and friends and colleagues have accomplished through their time in graduate school. And then lastly, I would like to thank once again the PhD graduating class of 2021. So maybe one more round of applause for all these amazing students. Congratulations, everyone. And I think Elchin is going to have the very last word.
So thank you, David. That was great. And thank you again, everyone, for being here with us today. And so we're done with our official ceremony. We can keep the Zoom ongoing if you want to set into groups, but you can, I'm assuming, can also, some of you are already like together in our groups of graduates, so I'm sure you're going to continue on celebrating throughout the day. So with that, I'd like to officially end the ceremony, and thanks again, David. Thank you, everyone, and let's give you guys another big loud of
congratulations.
Congratulations. Bye, everyone.
That was nice. Very nice.